Okay, now let's move on to an example that has polynomials. So we're trying to find the least common multiple of polynomials, and the rule is that we have to factor fully every polynomial and then look for common factors. Okay, so factoring fully means the very first thing we're going to look for is a greatest common factor. Okay, we want a greatest common factor to factor out. If they don't have one, then we move on to other types of factoring, but that's always a great place to start. So the greatest common factor here, notice that every term has a variable. Every term has an x. So my first step is going to be to factor out x. That leaves x squared minus x minus 2. Okay, then in the parentheses we have a quadratic. You know that a quadratic gets factored as the product of two binomials. The first two have to multiply to the first term here. So that's x times x. The last two have to multiply to the last term. So that's 2 and 1. Then we look at the signs. Remember that the last sign in the quadratic tells us if these are going to be the same or different. If it's negative, they're different, because a positive times a negative will give us a negative. Okay, so they have to be different. One has to be positive, one has to be negative. Once we know they're different, we slide over here, and this tells us what the larger one should be. So 2 is larger than 1, 2 should be the negative. So put the negative there, the positive there. We can do a quick FOIL to check it. X squared plus x minus 2x plus x minus 2x gives us a minus x for that middle term. Okay, fully factored. We're done with that. Let's move on to the second one. Again, it's just a quadratic, and it can be factored into two binomials. Again, first term, first terms. Last term, last terms. So we have a choice here. Either it could be 2 times 2 to give us 4, or it could be 4 times 1. So we need to figure that out. Which could it be? If we think about adding, so it's either 2 and 2 or 3 and 1. And I'm going to make that little notation up here just so I can see. They need to combine to negative 4. Is there any way to combine, sorry, this is not 3 and 1. I don't know where 3 came from. 4 and 1. Is there any way to combine the numbers 4 and 1 to get to 4, not by adding or subtracting? But I could add 2 and 2 to get to 4. So I'm thinking that 2 and 2 is going to be what goes in the parentheses. This time, the last sign is positive. That means that the signs have to be the same, and we slide backwards. We figure out what the signs are the same as. They're both negative. So I'm going to put negative, negative. Okay. Last step. We factored fully both of our polynomials, and now we find the LCM. LCM, remember that we take all the factors from the first one. A least common multiple. M stands for multiple. It has to be a multiple of this and of this, which means it has to have all the factors here, and it has to have all the factors here. What it doesn't have to have is repeats. And so we're going to start with one of them. We're going to write down all of the factors from the first polynomial. Okay, then we're going to move over to this one and say, do we already have these, or do we need to put these in as well? Well, the first one is x minus 2. We already have an x minus 2. So I don't need to write this x minus 2 because it's already covered over here. However, there's a second x minus 2. And over here, I only have one of them so far. So I need to add a second x minus 2 factor here. Our least common multiple is all 4 of these factors. Because it's a multiple of this one, it has all the factors of this one. And it's a multiple of this one because it has all the factors of this one.